Hello and welcome to Technically Speaking, where scientists and engineers come together to chat about a common interest, share knowledge and satisfy some curiosity. I'm Laura and I'm joined by Ellie to talk about meteorites and what you do if you found one or something else that was equally interesting. So Ellie, this idea for this episode came from you, so what's your interest in this?
Yeah, so I've actually been talking about this quite a lot of work about what to do if you would find a meteorite, how to tell if the rock you found is a meteorite in the first place, and then similarly things to do with other interesting things that you might find while out and about. So what to do if you found gold or gemstones or any of that sort of thing. And if you do find something, can you keep it? Which is a whole other matter in and of itself.
Oh, intriguing. So in theory, I should know something about this because my undergraduate degree is in earth science with astronomy. Sounds totally relevant, right? However, it was nearly 20 years ago when I finished my degree. So chances of me remembering most of what I was taught, and if it's actually relevant to what you know, I don't know, we'll find out.
I reckon you've got some knowledge stored in there somewhere in the back of that brain of yours.
Hopefully. See, I did start off with, so hang on, meteorites, there are asteroids, there are other heavenly bodies. What's the difference again? I did have to remind myself.
I definitely looked that up as well because I think they all get sort of used interchangeably, but they do actually mean quite a lot of different things.
Exactly.
So an asteroid is in outer space, and that's it. It doesn't come towards Earth. It orbits the sun, a small rocky object. A meteor is what happens when a small piece of that asteroid breaks off and then burns up, entering Earth's atmosphere, or then lands and becomes a meteorite. Does that make sense?
It does, yes. That matches what I remember of a meteorite being the thing that actually ends up on the Earth's surface. And meteors, I used to watch meteor showers quite a lot. I used to actually go and camp out during, what's the one in August, the really big one?
They come round periodically, I feel like.
Yeah, there's one that happens around, I think the peak is usually August 13th every year, and I always forget the name of it.
Oh, the Lutrids, something beginning with L?
Can't remember. Maybe one of our listeners can remind us afterwards. But yeah, I've gone out and camped out into like the Peak District, not a lot of lighting out there, and waited until it's gotten dark, which in August in the UK happens quite late.
Yes.
Especially when you're in the north, like I am.
Do you see them?
I've seen a few, but pretty much every time I've tried this, it's been quite cloudy. And I did get lucky one year where there was some breaks in the cloud, and it was quite spectacular. Like I was like lying on my back, giggling like a school child. 30-year-old woman on a hill on her own.
Guys, if you see Laura in the peaks in August, just know that she's meteor watching.
Yeah. But yeah, it is well worth making the effort because even if you don't see that many, what you do is very impressive.
I do think it's really cool to like actively see more than stars, like evidence of space, like other things happening outside of our world that you can then see from your little hill in the peaks. I think that's really cool.
Yeah, and it's definitely one of the more interesting things. I've definitely seen one or two that have been so bright that they cast a shadow.
That's cool.
Yeah, you wouldn't really expect it, would you?
I've seen the ISS from Earth. They had like a thing where it was like passing really close, and you could, if you were in the right place at the right time, you could see it like going across, which I thought was cool.
Yes, I think I've seen that once or twice as well. Again, quite surprised, wasn't expecting it.
Oh, you're up there. Are you okay?
But it does make me wonder. So you've got the meteor showers, which are a specific thing. I think I'd read they're normally like they're from comet tails, which is why they sort of come around once a year. So we sort of pass through it at the same point around the sun every year.
Oh, I suppose, yeah, that makes sense that they're like, it's an especially comety area.
Technical term.
Yeah, more likely then to be comets that would like burn up and create meteorites for us in those like specific areas of space, maybe.
Yeah, but I'd also read that they're quite small, so they're actually likely to fall to Earth as a meteorite, but you'll still see them burning up.
Oh, I see.
As they go through the atmosphere, was what I'd read.
Yeah, I suppose it would have to be like quite big to survive going through the Earth's atmosphere and then land and then be still a rock.
Yes, and what I'd read, I looked around for this and in a way I was disappointed that I couldn't find a straightforward answer to this, but I'm also not surprised that I couldn't find a straightforward answer. So I did read on How Stuff Works that they said approximately, depending on composition and how fast it was going and all sorts, anything bigger than a marble when it's in space has the potential that some of it might land on the Earth's surface in a form that you could identify it. But then they also said that dust will quite easily reach the Earth because it doesn't experience as much friction.
Oh, so there's just loads of space dust, but none of the actual big stuff.
Apparent loads, comparatively. Yeah, it's not like we're covered in space dust.
I was just imagining areas of like desert somewhere where it's just really dusty from all the space dust, but it doesn't work like that.
Apparently not. But then again, NASA said that, or seemed to infer that anything smaller than a car would burn up in the atmosphere before it ever reached the Earth's surface. So I'm like, well, which is it? A car or a marble?
Also, that is a very subjective term because cars are all sorts of sizes. Like an American SUV, surely that's going to get through, or at least some part of that will get through. But then if you're thinking like a Mini, maybe it's not quite big enough.
Fair enough. I guess I wasn't thinking about it on those terms. I'm imagining giant hands just hurling vehicles.
Just seeing how many, like when you were a kid and you throw rocks in the water and you throw the biggest one to make the biggest splosh. That's what I'm imagining.
Yeah, I did wonder though if NASA meant that it would all break up. So I don't know, maybe fractions or some bits of it would. So that those, if you have like a car-sized thing, it might break up into different bits, and some more marble-sized things might get to Earth, whereas everything else would be smaller than marbles. I don't know.
Yeah, potentially, or if the whole thing would just burn up completely.
Yeah, it depends how it fractures, right? And again, it also depends on the first reference I read, how stuff works said, it depends on what it's made of and how fast it's going. So there are many variables. So like I say, no surprise that I found conflicting answers.
Yes, I can see that, definitely.
But you said that you'd read quite a lot about meteorites falling to Earth and what they are and all that jazz. So have you got some fun facts that are better than my nobody will really tell us?
I love this for a fact, right? So there are meteorite detection groups, and the qualities of a meteorite are determined by the meteorites, which are the qualities that meteorites possess, and then the meteorons, which I think is amazing. So basically, apparently there are three main types: the iron meteorites, the stony iron meteorites, and the stony meteorites, which you might have seen coming. And it's all to do with like the minerals, the structure, the chemical makeup of these like meteorites of the different kinds. So some are extremely rare and can be super old, like 4.5 billion years old, which I think isn't Earth like around that same age as well. So like potentially even formed before the Earth was formed, which is pretty incredible.
So they mean they were formed elsewhere in space way back when and have come to Earth more recently?
Yes.
Right. I was having visions of the Earth forming around them for a second, and I thought that doesn't sound right.
I think the first thing you said is more accurate, that they were formed elsewhere. The Earth got formed, and then somewhere along the line they landed on Earth. But they are very dense. So if you picked up sort of a tennis ball sized normal rock versus a tennis ball sized meteorite, it would be incredibly heavy for its size because they're so super dense.
Okay. I've picked up some quite large objects made of lead before in my job.
Okay.
Do you have any idea how they would compare to lead? Because they were fairly heavy objects. You'd look at it and think, that's easy to pick up, and it was not.
I actually think that's a good point because it's the metallic iron within the meteorite that makes it dense. So, yeah, it's all to do with the chemical elemental makeup. So, yeah, I guess lead is heavier than it looks or denser than it is, and which is the same with the metallic iron within the meteorite.
Yeah. So I guess, it's just me being really pedantic now. It's like picking up a thing made of lead that people don't often do.
Isn't lead quite poisonous?
It was encased in something, so it was sealed.
Okay, good.
But yes, it is.
And also this isn't like totally yes or no, but often because of all the metallic iron within the meteorites, they're often magnetic. So you can have a little magnet be attracted to the meteorite, which is quite a good way to tell if it's just a normal rock or you've actually found something quite funky.
Ah, fair enough. So you can use a magnet and they should be heavier than your average rock.
Yes. And then there's all sorts of like fun little telltale signs of like when the meteorite has travelled through the Earth's atmosphere, the way that they have melted has like caused like a stony black, they call it like an eggshell outer crust, like a fusion crust. So like the way that it's melted has, formed this sort of melty crust over the top of the meteorite.
Okay, so they look kind of like iron balls, like you'd see in a museum of like, lead shot from way back when.
Yeah, to be honest, that is not a bad comparison.
Fair enough. So it could be a ball from a musket from one of the wars. It could be a meteorite.
Yeah, exactly. There's like a few other different things. There's something called the scratch test. So if you scratch the rock along an unglazed ceramic surface, there should be no streaks left behind. And it's a meteorite. But then if you get a streak, like a black or a red streak, they usually contain magnetite or hemonite, which is like not typically found in meteors.
Okay. I wouldn't ever thought to do that.
Yeah.
I think normally if I pick up a rock and scrape it along something ceramic, I wouldn't expect stuff to come off it necessarily. I know it depends on the rock, right?
Again, it's that thing of being a kid and being like, oh, this rock can make marks on another rock. And you like write your initials or,
Yeah.
that sort of thing. But yeah, I think this is quite an interesting one because it's basically they're trying to determine the chemicals within the meteorite. So if it's got these things, then it's probably not. But if it doesn't, then you might still be on the right track.
So is it worth knowing if you found a meteorite? Like, are they valuable, or do certain scientists really want to get hold of them so they can analyse them?
Well, so apparently I was looking into this and there's something that says per 50 cents, American cents per gram, which, considering how dense and heavy I said they were, could be quite a hefty amount of money. And then, depending on your specific meteorite, rarer stones can fetch $1,000 per gram. So yeah, potentially you could be making a little cash cow there for yourself.
No, but you wouldn't know until you get someone to analyse it.
Yeah, you definitely have to have it looked at to make sure. And actually, NASA, they said don't send it to us. They've had enough.
They've gotten fed up with people giving them meteorites.
Yeah, they're just not interested anymore because apparently they're not meteorite people. Their like focus is spacecraft and astronauts and protecting people. They just don't want strange rocks or strange rock pictures.
Makes sense.
They've got better things to do.
Like the aeronautics that's in their name.
Yeah, exactly.
And administering the space.
They've got telescopes to monitor and all sorts of things, so they haven't got time to waste looking at your rock pictures.
But who would be interested in them? Like, is there like university research groups or museums that you could send them to and they'd value them for you?
First off, you have to check if you actually are allowed to keep it. So in the US, if you find a meteorite on land that you own, you then own the meteorite. But if you find it under federal lands, so like I guess national parks in America or that sort of thing, it actually belongs to the Smithsonian Institute. So they might have dibs on your meteorite.
But they need to find out about it first, so just don't tell anyone. You can't make any money off it.
Just keep it under your hat.
Yeah. So yeah, do those tests, try and figure out if it is or isn't, or if it is just some lead shot. And then decide if you want to give it up or you want to keep it for yourself.
Yeah. I don't know, if I found one, I'd probably want to keep it, but I probably also wouldn't be 100% sure if it was one in the first place. And then do you risk being like, is this a meteorite, only for someone to tell you that it's a musket ball from 1603?
Exactly. And it sounds like they wouldn't necessarily look all that interesting.
Yeah.
So you're not going to put it on display.
I think that's the other thing, that for a lay person, they don't look that different to rocks. But the UCLA in London, the meteorite collection, said that they should contact like their local university or natural history museum, and they might have people that would be able to provide actual scientific tests to see if it was a real meteorite. Also, apparently they're private firms as well, and some places will test it and then buy it off you if you actually have found a good one.
That's handy. So in the UK, it's a bit more you can make some money off it and people will test it for you. So it is worth telling someone in that case.
But just be careful where you found it, because if you haven't found it on your own land, then it might not necessarily belong to you.
And so I worked out roughly, is it likely that one would land in my back garden, which is quite small.
Amazing.
There was a scientific paper out a few years ago where they calculated that about 17,000 meteorites land on the Earth's surface in a year. In 1 year, by the way.
That sounds like a lot to me. I was expecting less.
Yeah, but the Earth's surface is quite big, so that works out at about 1 every 30,000 square kilometres in a year.
Does that also include the ocean as well? Because
Yeah.
yeah, A lot of them probably are just sinking.
Exactly, so only a third of those is actually going onto the Earth. Although the paper did say that more tend to fall around the equator rather than the poles. So I wonder if that does kind of cancel things out a little bit. But even then, like just the UK, that means you get about 8 in the UK in 1 year. My garden's like this tiny, tiny fraction of a fraction of the UK. So chances of them falling on my land are very slim.
Very slim. They apparently occasionally they fall in people's on people's houses and stuff, don't they? There's like reports of people being like, "Oh, I've got a giant hole in my shed roof."
Yeah, I wonder if anyone's tracked how often that happens, because I reckon it sounds like it's sort of like a 1 in a billionth of a chance. But maybe there are some areas that for some reason meteorites tend to fall more often than others.
Yeah, there definitely are, because I was looking at how, like, where would you go to even find one? And there's areas where they are more common, I suppose is the word. And I'm trying to find the name of it, but it's like most of the meteorites that fall that then get found. Oh yeah, they're known as strewn fields or strike zones, and the Gold Basin in Arizona has yielded thousands of meteorites since the first one was discovered in 1995. So that's, yeah, not even 30 years, and thousands have been found.
Wow, someone needs to do the maths to figure out why that is.
Yeah, for some reason they said they like very barren areas. Like meteorites are more likely to find places that don't have any, like many other rocks and like deserty areas. And it did actually say that quite a lot fell in like the poles. I think mainly the North Pole, but like barren spots like the Mojave Desert or the Great Plains have more chance of finding one.
Is that because it's undisturbed ground? And some of these are really old, right? So they've been falling on Earth for ages, billions of years. So this is just places that we've not buried them accidentally by building houses and roads.
Yeah, there must be something in that, because this says the best hunting grounds are large barren expanses where meteorites tend to be black and therefore easy to spot. So I guess if there's just less stuff around, it's, easier to find them. And they said drier areas because it helps preserve the specimens if they are less altered by years and years of rain and snow and all the rest of it.
Okay, so I guess there's two slightly different things: finding one that fell to Earth at some time in the past and me thinking about, if one fell into my garden right now, what would I do?
Yeah, that's true.
And you said that they may or may not be precious depending on what's in them.
Yes.
I mean, how does that compare to finding things that are of terrestrial origins, like gold and minerals and stuff like that? What's better?
I don't know what's better. I think if you want to make money, you need to find something, either a lot of one thing or something super rare and therefore valuable. So there's some suggestion that black diamonds are formed in outer space and then come to space in meteorites. So if you were to find a black diamond, that would be exceptionally rare and exceptionally valuable, but equally very hard to find. But you're more likely to find more gold. If you hit a vein of gold, you could probably find a large amount, and then you'd have more, well, probably not more money, because black diamonds are incredibly valuable, but it might be more reliable.
But do you own the rights to that gold if you find it? Because I know I've been looking to buy some, a few fields to rewild just because I can. Why not? Turn some agricultural land into a wildlife space.
Oh my gosh, definitely.
Going into a whole different podcast episode here.
We must mention rewilding in every single one.
Of course, it's the future. But I happened to come across this thing about mineral rights, and I wouldn't necessarily own the rights to any gold that I found, even though it would be on or under my own land, because I wouldn't have the rights to it.
Yeah, I think actually in the UK, if you find gold or silver, they actually belong to the royal family, to the crown. So yeah, I don't think you would be able to keep it.
That just seems rude. They had nothing to do with it.
I mean, that is a great caveat, isn't it? To be like, yes, I am king, and also if you find any gold, it's mine.
Yeah, hasn't Charlie got enough money?
He's definitely got enough gold. I've seen that crown.
So the black diamond, do you know what is in that? Because I know that diamonds are it's carbon, and the atoms are in some particular arrangement that makes it pretty, because you get sort of, all the atoms line up and you can cut it quite easily, or hit it with a hammer and it fractures open, and you've got these sort of multifaceted shiny faces.
Yeah, so these black diamonds are called carbonado They are 2.6 to 3.8 billion years old. And this is interesting. This might help with the meteorite search. They've only ever been found in Brazil and like Central African Republic. But they think because they're so old, this was like they came to Earth a long time ago when the Earth was like still connected as one supercontinent. So that's why they're in those places, because then obviously over time it's split. But at one time it was all together. But they are polycrystalline or aggregate diamond material. Whatever that means.
Not actually diamonds.
But they basically just contain carbon that's been like smooshed. It says contain amorphous carbon, diamond, and graphite, which are all forms of carbon, but it's the way that they are arranged, their like structure is different than like a regular white diamond.
Okay, so I would imagine that the reason it looks black is because the atoms aren't all arranged in the same way. So you've got like areas of opacity.
I could see that being true.
Yeah, and I guess it depends on like how regularly they're spaced as well. So they might sort of be in particular regions, like create a layer with diamonds either side, and that layer might somehow be reflective in a particular way or absorb some of the light in a different way.
So if you're looking also at the money argument for finding meteorites and finding gems and all that sort of thing, the one of the biggest black diamonds was sold for 3.16 million in February last year. Just to give you an idea of the worth of some of these things.
Cool. So did they say how big that was?
Yes, it weighed 111 grams. So not very big.
So chances of finding one of those and correctly identifying it if it's inside some grey ball of metal and sending it to the right person and having everything line up to be able to just magically have millions of pounds. Quite slim.
Quite slim, yeah. Quite slim.
But we can hope.
But also then you need someone very rich that wants to buy it from you as well.
That is true, but I imagine that's probably the easiest bit of it.
Being like, yeah, look at my snazzy diamond, who wants to buy it? Maybe lots of people do.
Yeah, just go to the media, say you found this really rare thing, get whatever institute that is verified that it's a really rare thing to sort of do a bit of a press release. Create some hype around it.
Make a couple of TikToks. You're sold. You're done.
Exactly. Like those guys that did that drink, was it Prime? And people were like falling over themselves to get a bottle of it.
I can't believe that. That has come up so many times at work of people being like, but why? Like, is it even nice? Is it good? Is it just glorified Red Bull? Like, I don't understand anything about that.
No, but it's just the hype that was put around it, isn't it? It doesn't really matter what it was made of. It was made to be desirable.
Yeah, as soon as someone's got it, you've got to have it.
Yeah. Whereas I feel like diamonds, at least, they do have some practical purposes.
Yeah, I can see why. Like, diamonds at least have longevity as well.
Yeah, and you can use them. Like, you get diamond tipped tools and all sorts, don't you? They're really hard, so they have useful properties to them.
Apparently, this is also a thing about these carbonated diamonds, that they are especially dense, and it actually took 3 years to like polish and cut this diamond into like a shiny diamond shape, because otherwise they do just sort of look like rocks.
Yeah, I saw some images when I was doing some research of like lab-grown diamonds before they're cut and polished, and they look just kind of like lumps of glass.
That's the thing. I would 100% be like, oh, that's a cool rock, and then I just wouldn't. That would be it. My thought. I wouldn't be like, oh yeah, this is a 2.6 million year old diamond from outer space.
Exactly. And I spend quite a lot of time on the beaches around here, like looking at the little pebbles and things that wash up. So I live next to the Lake District, so we get a whole different range of different rocks, a whole different colours, and bits of sea glass and all sorts. So I may have at some point found a diamond and not known about it and just put it back on the beach.
I don't think Cumbria is a hotbed for diamonds, but who knows? Maybe it is. Maybe there is and no one has realised.
You never know. Or, because I live next to a really old seaport, there might have been some diamond smuggling at some point.
Oh, that's cool.
Yeah, there's a sunken ship somewhere with all this treasure in it, and it occasionally washes a bit up on the beach.
They do say that there is a lot of gold in the sea because of all the shipwrecks from like back in the day, and people carrying like literal treasure on shipwrecks that sank. There's like loads of gold in the sea. So yeah, maybe there's loads of diamonds in the bottom of the Cumbria rivers.
Who knows? I also found, sounds really daft now, an instructable on how to make a diamond in a microwave.
Oh my goodness. We need to do it. We need to do an experiment.
Well, the person that did it had photos of it, documented their entire process, and said they took it to a jeweler, a friend of theirs, that could confirm what's in it using official techniques. And they said, well, yes, I mean, it was absolutely tiny and it looked like nothing of interest at all. They said it does have some diamond-like properties, but it's not very high quality. It wasn't very exciting to look at.
Yeah, I suppose you need like high carats and clarity and all the rest of it, don't you?
Yeah, and this was like, a piece of graphite from a pencil. It's like mechanical pencils you can get.
Oh, yeah.
And you can get like the rechargeable graphite things. It was just like one of those, so it was quite thin anyway.
So how did they do it then? They just used the temperature of the microwave, or?
They put a dab of oil on it and let it soak into the graphite to apparently concentrate the heat, and then set their microwave to the maximum power and maximum amount of time, which is like an hour and a half or something.
Just going round and round and round for one like tiny bit of pencil.
Well, I think they put it right in the middle and they removed the rotating tray, and I don't know why this is important, but they put it in a ceramic crucible, so 2 coffee mugs upside down to form this little chamber. I don't know how that would make a difference necessarily.
I mean, I like the idea of it, but maybe the execution could do with a little bit of work.
Yeah, but there you go. It is feasible to make a diamond at home, but it's just not all that exciting.
Yeah, please someone try it and tweet us and tell us that you've done it.
Yeah, I've got to say, I didn't think it was worth my effort or the power either.
Yeah, electricity's expensive.
Exactly.
We can't run a microwave for an hour and a half.
No, not just for the sake of it. I mean, you can grow diamonds in the lab. I'm not sure that's the right term. Make diamonds in the lab relatively easily if you've got the right equipment. It's just a very high temperature, about 50,000 times higher than atmospheric pressure.
Wow.
And about 1,000 degrees C. So if you've got a machine that can go up to that temperature and pressure, stick some graphite in it. Yeah. Also probably quite expensive way to do it though.
Yeah. Maybe we'll leave it to the professionals.
Yeah. I'd also seen something in the news not so recently, going back to what you were saying about finding gold, about some metal detectorists that found a cache or a hoard, and then they tried to sell it on the black market and they got found out. And you're not meant to do that, as you just said. You're meant to declare it.
You can't blame them for trying. I mean, if you thought you could get rich quick doing that, then... But I think also there's a thing about like historical significance and importance. Like just finding a lump of gold is one thing, but finding like gold coins from 10 AD or something like that is making, it's like culturally relevant, isn't it? So you can't just profit from that. I think you have to give it to a museum or something.
Yeah, I can't remember exactly what it was, but I'm sure I read that if they'd gone through proper channels, they would actually have gotten more money than attempting to sell it on like the black market or the dark web or wherever.
Oh, you heard it here first. Do things officially and you might get a cut of the cash.
Yeah, unless it is definitely gold and it's not of cultural significance, and then it just goes to the king. Don't do that.
Yeah, that's true. In which case, probably just keep it and then subtly slide it to your mate. No, I'm not advocating for backyard dealings in gemstones and gold.
No, it's a nice idea though, going out to try and find something valuable. People do go panning for gold in all sorts, don't they?
Yeah, there's like official places as well where you can pan for gold, and if you do find it, it's legally yours to keep. Like that's like the agreement of the place that you go to. Like I've done it in Australia. We went panning for gold. We didn't find anything, but it was quite a fun day. Yeah. And then they have like tiny little gold things in the gift shop that you can keep, that you can buy and keep.
Pretend that you
found it.
I like your cat making an appearance there and just going, whoa!
She is so loud. I swear she has the loudest meow, and she just likes to talk. Like there's nothing, she's been fed, she's got plenty to drink. My partner's downstairs, so she's got someone to interact with, but she just loves to shout about different things.
Yeah, I want to know who you're talking to.
I was doing a podcast earlier and I'd done like 99.9% of the whole thing, and then out of nowhere she sprang onto the laptop and I was like, oh my god, no, I've got to save it. And I hefted her off, rather undignified, but I was like, I need to protect the recording. So she always knows she always picks her moment to appear.
Oh, actually, my dog has now just walked in. I feel like this might be signalling an end to the podcast episode.
The pets are demanding that we return to them.
Yeah, like, it's evening, what are you doing? Come play with me. Come into the garden and wait for that meteorite to fall.
Amazing.
I think that probably is a good place to bring it to a close. What's your cat's name?
Sparkles.
Sparkles and Smudge demand that we do something else now.
Yeah, but we've been told in no uncertain terms to get off Zoom and go into the real world.
Oh, it's like saying I'm not a real person. So it sounds like chances of finding a meteorite in the UK anyway, are quite slim. So if you want to go looking properly, go somewhere where there aren't a lot of people and you might find a historic one. And you never know, it might be worth something, or there might be a new scientific discovery made, like the structure of these weird black diamonds.
Yeah, absolutely. There are groups as well. If you are genuinely interested in finding meteorites, there are forums and groups and all sorts of different pages that you can go on and have a go.
Oh, so there you go. Get on those forums and find out if you really do want to do it, or just do what Ellie did and go to Australia and pretend to pan for gold.
I mean, I really panned for gold. I didn't find any. But you might, you've got to keep trying.
Yeah, and you never know, you might get rich. It sounds like it's very slim chance, but you never know.
Exactly. You've got to be in it to win it.
And on that note, I think that's it for this week. So if you've enjoyed listening, come and find us on social media and have a chat with us. Tell us what you liked. Tell us what we could improve if you prefer.
Tell us if you made a diamond in your microwave.
Oh yes, please do, because we can't afford to, apparently. We would really like it, actually, if you enjoyed this episode, if you give us a little bit of money on our coffee fund, pay for a cup of coffee or tea or a beer, whatever you takes your fancy, and keep the podcast going. So until next time, thanks for listening.
Bye!
The views expressed in this podcast belong entirely to the person that said them. They do not represent any industry or organisation. If you enjoyed listening to these views, it would really help us out if you could rate us, leave a review and tell a friend. This podcast was sponsored by no one, but if you're interested in funding us to continue to have frank discussions about science and engineering, please get in touch.